Earth looks like a miracle from far away. Blue oceans, green continents, clouds wrapping the whole planet like a living skin. But get closer, and the miracle becomes patchy. Huge regions are frozen, scorched, dry, dark, or starved of nutrients. Life survives here with astonishing stubbornness, but Earth is not a perfect garden. It is a brilliant compromise. So what would a planet look like if nature had better starting conditions? Astronomers now suspect that Earth may not be the best possible place for life. Around other stars, there may be worlds larger, warmer, wetter, and more stable than ours. They are sometimes called superhabitable planets, not merely habitable, but almost unfairly generous. Let us build one from the best science we have, not as a claim that it exists, but as a blueprint for what life might do when the universe gives it every advantage. The first decision is not the planet. It is the star. A yellow star like the Sun is powerful and familiar, but it brightens as it ages and gives complex life only a limited window. A red dwarf can live for trillions of years, yet many are restless when young, blasting nearby planets with flares. The sweet spot may be a quieter kind of star, an orange dwarf. Red dwarfs are tempting because they last almost forever, but their habitable zones sit close in, where a planet can become tidally locked, one face trapped in daylight, the other in permanent night. Worse, young red dwarfs can rage with radiation strong enough to strip atmospheres and boil oceans. Time alone is not enough. A living world also needs calm. So we place our world around an orange dwarf, smaller and cooler than the Sun, brighter and gentler than a red dwarf, and stable for tens of billions of years. It gives life something Earth will never have: almost absurd patience. Around this star, evolution is not racing against a short deadline. It can experiment, fail, recover, and try again across oceans of time. Now we build the planet. Call it Hestia. It is a super-Earth, about 30% wider than Earth, with far more surface area and almost twice the mass. Gravity is stronger, but not crushing, perhaps 20% above what we feel here. That extra size matters. It means more room for continents, seas, weather systems, and evolutionary experiments. But size alone does not make a paradise. Hestia begins as a dead rock until its interior comes alive. Deep below the crust, a large metallic core churns inside a hot mantle. That motion creates a magnetic field, an invisible shield that bends away charged particles from space. Without it, solar storms would slowly sandblast the atmosphere away. With it, Hestia can hold its air, protect its surface, and keep the stage open for biology. The second machine is plate tectonics. On a world without moving plates, heat and tension can build until the planet releases them catastrophically. Moving plates do something subtler. They recycle rock, pull carbon into the deep, release minerals back to the surface, and keep climate from drifting too far in one direction. The crust becomes not a lid, but a conveyor belt feeding life with chemistry. A perfect world should not be perfectly still. Life becomes richer when it must adapt. So Hestia has mild seasons, not brutal swings, just enough change to trigger migrations, blooms, and cycles of scarcity and plenty. Its day is long, about 36 hours, giving weather more time to breathe. 4 small moons stabilize the planet and pull its oceans into complex rhythms. Then we design the land. Earth has a problem. Many continents are so large that their interiors sit far from water. That distance creates deserts, poor soils, and harsh extremes. Hestia avoids megacontinents. Its crust breaks into many smaller plates, lifting island chains and narrow continents instead of vast dry interiors. Almost everywhere, land stays close to sea, rivers, rain, or wetlands. The result is an archipelago planet. Not 1 or 2 great landmasses, but countless islands, island arcs, lagoons, deltas, cliffs, and inland seas. Coastline is the engine here. It mixes nutrients from land and water, creates barriers that split populations apart, and then gives them different problems to solve. Isolation makes species strange. Contact makes ecosystems dense. Hestia has both in ridiculous amounts. Hestia is also warmer than Earth by several degrees Celsius. That sounds modest, but it changes everything. On Earth, cold locks, away land beneath ice, slows metabolism, and compresses life into favorable belts. On Asteria, even high latitudes can stay green. Polar forests replace ice sheets. The tropics expand. The planet becomes less like a patchwork of refugees and more like one enormous living laboratory. Under an orange star, plant-like life may not look like ours. Earth plants reflect green light, but on Asteria, the best strategy might be darker pigments that swallow more of the softer amber radiation. Forests could shimmer in black-green, violet, copper, and deep maroon. From orbit, the planet might not look emerald. It might look like a dark jewel wrapped in clouds. Every island becomes a separate experiment. Some grow thorny forests where slow predatory plants fire chemical darts. Others rise into foggy plateaus ruled by towering fungi and armored crawlers. In warm valleys, feathered climbers leap between dark branches while pollinating insects the size of birds drift through the air. None of these creatures need to be familiar. They only need to be plausible products of abundance and isolation. The sky is not empty space above the living world. On Asteria, it becomes an ecosystem of its own. Because the planet is more massive, it holds gas more tightly. Air pressure near the surface is roughly 1.5 times Earth's. The atmosphere is thicker, richer in oxygen and carbon dioxide, and heavy enough that wind, sound, and flight all behave differently. More oxygen is dangerous. It can make fire easier to start and harder to stop. But Asteria's warm oceans feed a planet-wide water cycle. Humidity rises, storms bloom, and rain returns again and again before wildfires can become continental disasters. The same atmosphere that raises the risk also helps contain it. Life gets the benefits of oxygen without letting flame become the dominant predator. High oxygen opens doors that Earth keeps mostly closed. Creatures that rely on diffusion can grow larger. Mussels can burn energy faster. Predators can launch sudden bursts of motion, and prey can answer with equally violent escapes. Imagine insect-like giants browsing in swamp forests, not monsters for spectacle, but organisms made possible by air that carries more chemical energy into every breath. This makes Asteria louder, faster, and more restless than Earth. Food webs do not sit quietly. Hunters accelerate through wet undergrowth. Herds scatter in coordinated waves. Small animals exploit every gap in roots, bark, and canopy. Evolution rewards speed, signaling, poison, armor, cooperation, and deception. The planet becomes a pressure cooker for invention, with each niche pushing the next one to become sharper. Then life discovers the cheapest highway on the planet, the air. On Earth, flight is expensive because our atmosphere is thin. On Asteria, denser air provides more lift. Even with stronger gravity, wings can be smaller, and flight can cost less energy. Over billions of years, not one branch of life, but many may rise upward, turning the sky into a crowded continent without soil. Some flyers might never truly return to land. Great filter-feeding animals could cruise through cloud layers, swallowing swarms of tiny winged organisms like living plankton in an aerial ocean. They would touch the ground only at birth, death, or not at all. Beneath them, smaller predators, gliders, and drifting colonies would fill every altitude. Asteria's sky would not be background. It would be habitat. Thick air also carries sound beautifully. Asteria would be almost impossible to silence. Calls would travel through forests, across water, and between cloud banks. Some creatures would use noise to warn allies. Others might weaponize it, masking the direction of an attack with echoes and false calls. On this world, camouflage is not only color and shape, it is also acoustics. The largest ecosystem on Earth is the ocean, but most of it is dark. Sunlight reaches only the upper layer. Below that, the deep sea is vast, mysterious, and often poor in energy. Life exists there, but the engine of the food web starts near the surface. If we want a planet bursting with marine diversity, we should not make oceans merely wide. We should make them bright. So Asteria has plenty of water, but not oceans as deep as Earth's. Much of its sea floor lies only 100 or 200 meters below the surface, inside the sunlight zone. Photosynthetic life can carpet the bottom. Nutrients do not disappear into unreachable darkness. Almost the entire ocean becomes a working factory for sugar, oxygen, shells, reefs, predators, and symbiosis. Shallow oceans have costs. They warm and cool faster. Storms can become stronger. Seasonal changes may churn the water violently. But disruption is not always the enemy of life. It breaks monopolies. It opens space. It throws nutrients back into circulation. On Hestia, storms do not erase ecosystems. They keep them from becoming too settled. In those warm, shallow seas, reef builders can become architects on a planetary scale. Imagine living megacities thousands of kilometers long, built by patient colonies that grow, compete, fuse, and fracture over ages. Every ledge is real estate. Every tunnel is shelter. Every color hides a chemical signal or a predator's trick. The reef is not scenery. It is a city made of bodies. Around the reefs, forests of algae and kelp-like organisms rise through warm currents. They slow the water, catch sediment, shelter young animals, and feed entire chains of grazers and hunters. In one bay, pseudo-crabs might farm mats of glowing algae. In another, fish-like reptiles might herd small swimmers into curtains of living rope. The ocean repeats the same lesson as the land. Edges create opportunity. The most explosive edges are coastlines. Land feeds the sea with minerals. The sea feeds the land with storms, fish, salt, and migrations. Birds, swimmers, climbers, burrowers, and ambush predators meet in the same narrow bands. Earth already shows how rich these places can be. Hestia multiplies them until coast is not a border on the map, but the dominant shape of the planet. Earth may host millions of complex species. Hestia could host far more, perhaps tens or hundreds of millions, depending on how long stability lasts and how often disasters reset the board. The important number is not exact. It is scale. More surface area, warmer climates, shallow seas, dense coastlines, thick air, and long stellar life all stack in the same direction. They give evolution more chances. Would intelligence appear there? It might. A world with endless habitats creates endless problems. Tool use, navigation, communication, memory, social strategy, and cooperation. Perhaps intelligence emerges not once, but several times, isolated on different island chains or in different coastal basins. One culture builds in wood and shell, another in stone and woven glass. Another learns metallurgy under permanent rain. Their philosophies would not begin where ours did. Humans grew up on a planet where life is rich but fragile, where winter kills, drought empties land, and deserts remind us that abundance can vanish. Hestian minds might see nature as overwhelming, almost impossible to wound permanently. Would that make them gentler, because life is sacred? Or more careless, because life always grows back? If they ever looked at Earth, they might not call it paradise. They might see a cold, unstable, half-starved world with too much deep ocean, too many deserts, too much ice, and only thin green scratches across the continents. To them, our planet could look like a harsh frontier where life survives by stubbornness rather than luxury, and they would not be entirely wrong. We do not know whether Hestia exists. It may be only a thought experiment, a mirror held up to our own lucky planet. But the universe is enormous, old, and generous with planets. Somewhere around a quiet orange star, there could be a world where life has more time, more space, more water, more edges, and more chances than Earth ever had. Not just alive, but overflowing.